Okay, so make sure you know how to label this diagram. I won't ask for the definitions, but I will ask you to label. And do you need to know the spelling? Yes, okay. I'm already not asking you for the definition. The least you guys can do is know how to spell it. Okay. So this is arc, not arch. Okay, I've seen people spell it very differently for me. Okay, and not arc with a K, so ARC. So any part of the circumference. Okay. And then as you guys know, the whole perimeter around is called the circumference. Diameter, diameter and radius, you guys know already. What's the difference between a secant and a chord? So what's the difference between these two lines right here? Derek.
Chord is just like a harp.
Say that again.
A secant keeps going, chord just inside circle.
Right. Okay. So a chord stops at your circumference. So it has 2 points on the circumference. A secant cuts through it. Okay. So that's the main difference. Then what about tangent then? What's the difference with a tangent? Take a look at the diagram. Yeah, Justin? Yeah. What's different between this line and this line, Justin? Give it a try. Tangent? Yeah.
Doesn't go through, it just touches one point.
Perfect. Exactly. It touches 1 point. Okay, so it touches 1 point on your circumference. This has 1 point. This has 2 points. This cuts through your circle. Okay. The tangent rule is a very important one that we'll go over today. It's called the tangent radius property. Do you have a question, Claire? No? Okay, sorry. Don't get distracted. Okay. So tangent radius property, that's what we're going to focus on today. The last two, central angle and inscribed angle, we'll talk about that tomorrow in tomorrow's lesson. Again, a big lesson tomorrow on that. Okay, so let's go over what is the tangent ratio property. Example 1. Zoom this in. Okay, so example 1, point O is the center of the circle. AB is the tangent to the circle. In triangle OAB, AOB is 63 degrees. So what is the other angle? So what's so special about the tangent radius property is that it always forms a 90-degree angle. So your radius and your tangent always makes a 90-degree. Always, always, always. So I could draw it anywhere else on the circle. That angle is always 90. So if you know that this is 90 and this is 63, you just have to simply subtract it from 180 to get angle B. Okay. We can either write angle B as OBA, OBA like this, or we can just say angle B like this. And so when we subtract it from 180, we get 27. Okay, example 2. So again, O is the center, CD is the tangent. Now, if I give you length this time instead of angle, length CD is 15 and length OD is 20. What is the length of the radius? So OC, what is the length of OC? Think about how to solve this one. Okay, so who has an idea how I can solve for the third side? Pythagorean theorem. Wow, how did you guess? Yes, we have been working on that for like the whole last week. Since I'm looking for the side length right here, I'm given C. I'm going to do the subtraction. Okay, so that 20 squared, take away 15 squared, square root that, I get 13.2 centimeter. Okay, and in fact, what I just found was the radius of OC. Okay. Okay, so if I if I didn't give this diagram, you might have a lot of trouble finding, like what's the radius? Why is it suddenly asking me the radius? You just gave me 2 length. But because we know about the tangent radius property, that it's a 90-degree angle, then we know that we can apply Pythagorean theorem. Okay, example 3. Okay, this one is a little trickier. So an airplane A is cruising at an altitude of 9,000 meter high. The cross section of Earth is a circle with radius approximately 6,400 kilometers. The passenger wonders how far she is from point H on the horizon when she looks out the window. Calculate the distance to the nearest kilometer. Okay, so first off, when you look at this diagram, what pops up in mind? When you look at this triangle, what do you notice in the diagram? You should catch it. Okay. What's wrong with the diagram? Capuchin, do you see what's wrong with the diagram? Okay, oh, I do see the triangle. What about the numbers? Okay, what's different? Unit, that's right. Okay, so one is in meters, one is in kilometers. So let's say I change that 9,000 meters. What is that in kilometer? 9. That's right, 9. Yeah, believe in yourself, Louis. You just had a whole test on this, right? Conversion. All right, so this is actually 9 meters, 9 kilometers. So what is the whole distance right here? The whole length of this line is, Vincent? 6,409. That's right. Now, I know I'm supposed to form a right angle triangle right here. Okay. How long is this blue line? Justin, how do you know? Exactly. Excellent. So I actually remember radius is the same throughout your circle. So if this part of the line is 6,400, which is the radius, this is also my radius. So this is 6,400, this is 6,409. So to find HA, I do Pythagorean theorem again. All right, so square root it, I get my answer, 339.5 kilometers. So the tricky part is like labeling the numbers. Once you have those numbers, you know it's just Pythagorean theorem, Pythagorean theorem, Pythagorean theorem. Did it say? Oh, yes, it did. Okay, so what would your final answer be? Yeah. All right, so because it does say nearest kilometers, so it's 340 kilometers. Okay. Thank you, Derek. Okay. 3 more example. Example 4. Point O is the center of the circle and the line segment OC bisects the chord AB. What does the word bisect mean? Think of science. Think in science, yeah. Cut right in the middle, cut it in half. That's right. So you know how you guys like dissect a worm? If you say bisect a worm, you're actually like cutting it exactly in the middle, cutting it in half. This bisect word, you'll use it a lot in grade 10. Okay, so what it means is right here. Okay, let's say you guys didn't see that yet. Okay, I have these right here. Okay, so I can tell you OBC or angle X is 33 degrees because isosceles. But how do I know this is an isosceles triangle? Vincent. Excellent. Okay, so OA and OB are both your radius, which means they are the same length. So that means this is an isosceles triangle. By the way, what is line AB called again? What is line AB called? We just learned this name today. Chord. That's right. Okay. So let's see. You guys need to know these names. Line AB touches 2 points on your circumference. That's a chord. Okay. Since I know that this is 33, this is 33, this is a 90-degree angle. What is angle Y then? Let's see. Who should I pick on? Um, uh, Adelis? What is angle Y? Okay, so in this triangle right here, you know that the three angles have to add up to 180, right? Yeah, you can use your calculator. So one angle is 90, the other is 33. So the third angle is perfect. Good job. All right, so 57, 33, and because you know that's 90. How do I know that's 90? Because it bisects right in the middle. So and actually that's another property. A chord, and if you bisect your chord, it's always at 90 degrees as well. It's one of the circle properties. Okay. So knowing these properties can help you solve a lot of angles in a circle. Okay. Example 5. AB is the diameter with length 26. CD is the chord that is 10 centimeters from the center of the circle. What is the length of the chord CD? Give answers to the nearest 10. Okay, so I want to find out how long is this chord right here. All right, I know that this bisecting line is 10 centimeters. So the vertical is 10. What is the diagonal right here? How long is that? How long is that blue line? Yep, 13 because radius. Good. Okay, so a lot of this, especially in a circle, you know you're always dealing with the radius. So, but it's also sometimes hard to see. So keep that in mind that you actually know your radius. Okay, so if I do that, I can figure out how long the bottom length is, which is 8.3. So is that my final answer then? Genevieve? No, why not? Right. Okay, so in this triangle right here, I found ED. But I want the whole chord. I want the whole chord CD. And because I know that my chord, when I bisect it, when I bisect the chord, this and this are equal. Okay, so that means I have to times it by 2, and I get the full length, which is 16.6. Okay. Okay, and the last one. This one is the trickiest. Okay, so a horizontal pipe has a circular cross section with center 0. Its radius is 20 centimeters. Water fills less than 1/2 of the pipe. The surface of the water is 24 centimeter wide. Determine the maximum depth of the water, which is CD. So I just read a whole bunch of things right here, but if this confuses you, then don't read it because all you need to know that is at the end right here, you're looking for CD. All right, you're given the diagram, You're looking for CD right there. Okay. So just because it's a word problem, don't let it confuse you. Right? You are given a diagram. So if you're really stuck on a test or quiz or anything, just do whatever you can, like whatever info that you can find out of this, you'll get part marks. Because this is a confusing question. So I know that A to C is 12 because they told you that AB is 24. So again, I have this right angle triangle. I can find out how long OC is. So I'm going to do the subtracting one. OC, I get 16. Okay, but that's not what I wanted to find out. I want to find out what CD is. Who knows how long CD is? Okay. Oh, Justin, what is it?
4 centimeters.
4 centimeters. How do you know?
Because that's the strips of the water 22 centimeters, and then the radius is 20 centimeters. The split the 24 centimeters in half, it's 4 centimeters, and do the Pythagorean theorem to get the length of O to C, and then it's 16.
Okay.
Minus 20, the radius.
Yes.
Minus 16 from 20, get the stack of 4.
Perfect. Okay, so what's tricky? It doesn't look like it, but OA is actually the same length as OD right here because they're both your radius. Okay, so if I know that this whole line OD is 20, when I subtract it, that's how I get the 4 for CD. Keep in mind, this is how you write the length of a line. So you see OA, I would write OA as 20, OD like this. This tells me, when I write OD like this, it tells me this is the length. Right, Peter and James? Right? Right. Okay. So if I write just the letter, when I write just the capital letter, I'm referring to an angle. If I write 2 letters side by side like this, I'm referring to the length of that line. Okay. So I still see some people, so today's lesson, we did a whole bunch of angles and length inside a circle, and all of these we use Pythagorean theorem. Okay. What I don't want to see is I still see some people do this. Like, so for example, this, let's say I say angle A is 30 degrees and I say length A is 38 centimeters, something like this. Okay, remember this is an angle. Angle goes in the corner. Okay, I see people write this. Okay, it's an angle, so it's not a. This is suggesting that it's a length. So angle is in the corner, like this. Angle A. This is a length. So I'm talking about this right here, which is 38 centimeters, like that. Okay, so don't mix up angle and length. I could another way of writing a length is writing it like this as well. So BC, then length BC. I could also write it like this. Okay, so know the difference between these two so that you don't mix up angles for a length and a length for an angle. Okay, so for the rest of the class and homework, just page 9. So yeah, only page 9, just these ones right here, practicing more on the tangent radius property. And then tomorrow, as I said, we are going to learn the important lesson with the inscribed angle and central angle. So this is very important to know for your quiz. So just looking ahead, that's what we'll do tomorrow. And then that's it. And then on Wednesday, we'll review. We'll do this review and and then the quiz on Thursday. Okay, so you can see that's why I made it a quiz, because it's only 3 sections in chapter 9. Angles in a triangle, angles in a circle, and more angles in more properties of a circle. Okay.